Hello everyone. Let's talk about simple linear regression. So this is one of the multivariate analysis. It is dependent. It comes independent in multivariate analysis. So we have simple linear regression. First of all, we need to understand what is regression. Regression means we are just showing the relationship between two variables, right? I mean to say, if you have a income variable which is get affected by person education, right? So the education you can consider it as a predictors which affect the income. So based on the education, people earning is different. So how much the predictor influence the dependent variable? That's what this regression analysis shows that. So we have to follow a couple of things for this simple linear regression also. So first of all, we need to know this simple linear regression. We have to understand the linearity, right? We have a couple of formula for population. We consider it as y equals to alpha plus beta x plus u. So here this alpha means this is the intercept, right? This is the y intercept, and beta means that is the value, and this is, suppose this is a dependent and this is the independent value. This is the error, u means error terms. So we are not going, maybe most of the people do not consider it as a population, right? So we have to develop, we have to use the sample. For sample you can use what you can use in sample you can use y hat. We can call this as a y hat, this symbol, sorry, I have to erase it, y hat, this symbol, right? So what we can call it as a plus bx. So like this we can consider it in a sample population, and we have a couple of assumptions in order to successfully tell that this is a simple linear regression. We can perform simple linear regression, right? We have a couple of assumptions. First, let me write when this simple linear regression we have to consider it simple linear regression. For that, what we do? For simple linear regression, we need to know, right, when we have to do a simple linear regression. When we do, first we need to check whether the dependent variable is normally distributed or not. So we can call it dependent variable is a db is normally distributed or not. I know we can say that. How will you confirm that normally distributed or not? So first we can do histogram. If it is bell shaped, then it is normally distributed. Histogram, right? And QQ plot, I can say as a QQ plot. So histogram, if it is bell shaped, means normally distributed. If QQ plot is diagonal, means normally distributed. So we need to consider these two assumptions. And another thing, what this is the plot, right? What is the statistical test? We do Shapiro test, right? Shapiro test. We can call GOF test also. So here what happened? P value greater than 0.05. Now if it comes means then this is normally distributed. Then के भन्न सकिन्छ त, then we can call it as normally distributed, right? So this is Shapiro test is goodness of fit. We need to check if it is p-value is more than 0.05, then we can say that it is normally distributed. So this is the first thing we have to check, right? And second, what we will do now, think that then it is normally distributed. You got that variable which you are going to predict it, right? Predicted variable that is normally distributed. I mean to say dependent variable is normally distributed. You confirm through graphical plot, we can which we can say histogram, and also we can say QQ plots, right? If it is diagonal means confirmed. And if those histograms and QQ plots not identified that those things are not normally distributed, then we go for Shapiro-Wilk test. That test confirm, that is goodness of fit test. That test should come insignificant p-values, means this is normally distributed. I mean to say p-value is greater than 0.05. Now let's move to the second one. What do you call second one? Now it is confirmed. Now what we will do? Now we will fit regression, right? Let's fit linear regression. We have a formula, right? What? Y hat a plus bx. So in this formula we have to fit linear regression. Then we are going to fit linear regression, right? Before fitting to the linear regression, before this there is one more step, 1.1 I can say. It is linearity. We need to check linearity, right? So linearity we have to confirm linearity. Linearity, how will you confirm? Through fitting the dependent and independent variable to the regression model. So if we call it R program, right? How will you fit in R program? R program, we just say model equals to LM as a linear. If earlier I gave you example, right? That is education, right? Education tilde, we can consider education is a predictor. What is the dependent variable? Income. So income. Then comma data equals to, maybe this is an empty cars data set. If we consider this is empty car data set, then we should give data sets empty cars. Means from empty cars data sets we extract education and income variable. So now what happened? Now third steps, what happens? Tell me. There is F statistics we need to say. Then we have to see this p-value. Now what happens? P-value is less than 0.05 means what do we call? Model significant. Right? So we need to see the R also. If R square, right? You have to see the R square. R square, if it is significant means no matter if R square is 0.50, less, greater also okay, or less than also okay, because overall model is fit, right? So we can say that this model is fit because a p-value is significant. So we can say that education has a impact on what? Income. So based on the education, there is a significant. We can say, if we talk about hypothesis, right? We are accepting alternative hypothesis because it accepts there is no significant effect, means that is null hypothesis, and it is less than 0.05 means we are accepting alternative hypothesis that there is a significance. Okay, so how, let's interpret interpretations. My interpretations based on the analysis, you can call it as analysis, p value is less than 0.05, which says it is significant model. R square, also suppose 80% states that what you can call it as R square means when education's being a good predictors for income, right? Income. So we can call another meaning. So income 40%. We can say like this. See, 80% of variation is explained by independent variable. So you can call it like this. Maybe we have to check it out. Okay, thank you so much.